Dear students, welcome back. Today's topic is the Boolean algebra or the laws of Boolean algebra. The topic code is the ELEC-DIGIE-S4. Boolean algebra, as we already explained in the introduction, that it is the algebra of logic. The Boolean algebra uses a set of laws and rules to define the operation of digital logic circuit, as well as the logic symbols 0 and 1s being used to represent a digital input or output. We can also use them as constants for a permanently open or closed circuits or contact respectively. A set of rules of laws of Boolean algebra expressions have been invented to help to reduce the number of logic gates needed to perform particular logic operation, resulting in a list of functions or theorems known commonly as the laws of Boolean algebra. The purpose of the Boolean algebra is that it simplifies, it reduces the complex or the huge lengthy logical expressions to simple expressions. So you go through that, and we will just quickly go through these are laws of the Boolean algebra along with the truth table. First, here we have, there is no particular order, but we can say that a plus 1 is equal to 1. This is the equivalent circuitry, and this is called the law, or the rule is called annulment. Here, very simple logic, you can see that a can have two values, 0 or 1. If you put the a value, each of that value, that is 0 or 1, if you put 0, 0 plus 1 is 1. If you put 1, 1 plus 1 is 1 in the logic sense. So a plus 1 is equal to 1. Similarly, a plus 0 is equal to a. This is a normal, as in decimal we have normal algebra as well, that anything which is added to 0 is the same that thing, and this is called the identity law, the law of identity, and the law of annulment. Annulment means a plus 1 is equal to 1. So this equivalent logic circuit, that this switch is 1, that is already 1, which is closed, and this other one switch is the either open or closed, 0 or 1 we can say. If a current is going through, allowed to pass through, so whatever the consequence may be, if that here in the circuit the current will pass through whether the switch is open or closed. This is what that means. In the other the law of identity, we say that this circuitry is a switching circuit. The switch is open, there is 0. Okay, so it has two states, either 0 or 1. When switch is 1, the output will be equal to 1. That means it is closed, a is equal to a. But when it is open, obviously when a is 0, obviously output is also 0. Another, in multiplication, the law of identity. So law of identity are defined additions, multiplications, both. So in case of the multiplication, a dot 1 is equal to a. This is called the law of identity in the product or the AND. A in series with closed A, this is equivalent circuit. So if a is 1, and this is obviously 1, already switches in the 1 state, which is the closed state. So that is the a is 1, so it is closed, then obviously the current will pass through. So if a is 1, the output is also 1, so that is a is equal to a. But a is open 0, then the output is also equal to 0. Means a, whatever the value of a it has, that is the value at the output. This is again the law of annulment for the product. A dot 0 is equal to 0. So when a, again the similarly the switch is open or 0 state, a is 0, obviously the output is 0, so a 0 output is 0 means whatever you multiply the binary variable with that 0, you will get the 0. Similarly, when a is 1, again a is 1 means it is closed still, but this is open, so output is equal to 0. The idempotent this is the law which a plus a is equal to a. Here in this case we get whatever the value put, 1 plus 1 is equal to 1, 0 plus 0 is equal to, because it will have the same value, we don't have that 0 and 1. Okay, 1 plus 1, a will have value 1, 1 plus 1 is equal to 1, 0 plus 0 is equal to 0. So whatever the value of a will have, you can replace a with the a plus a in the logical expression to simplify the expression. So this is the parallel switching of that. So we have the further a dot a is equal to a, yes, means if a is 1, 1 into 1 is equal to 1, and 0 into 0 is equal to 0. So this is again, this you just apply the same switching circuitry, the dependent law for that. Then we have the double negations, means the double complement. If you have a complement and you take another complement of the complements, you get the same value a. Okay, so that is the double negation or double complement we call it. A plus a complement is equal to 1. So here very simple, put the value of a's and see what result you get. If you put value of 0, here it is 0, 0 complement is 1, complement means inverter. So the 1 plus 0 is 1. If a is 1, is 1 plus, and 1 complement is 0, 1 plus 0 is 1. So we get this is a complement law, double complement law. This is again the further complement, a dot a complement will be equal to 0, always equal to, because if a value has 1, so 1 complement is 0 and 1 into 0 is 0. If a is 0, then this is 1, but 1 into 0 is 0, always equal. So this is very useful. These are useful laws or the rule of the Boolean theorem, Boolean algebra. Similarly, a plus b is equal to b plus a. This is a commutative law, you know it very well. Similarly, a dot b is equal to b dot a. This is also commutative law. This in addition, this is for the multiplication. Similarly, De Morgan's, we will go through De Morgan's later quickly, but it just give you the quickly that De Morgan says that the sum of the complements, okay, if there are two variables or more than two variables and number of variables, they are added together and you take the complement, that are equal to the result is equal to the product of the complemented variables. Whatever inside that complement you have got, take the complement of each and multiply them. So this is got invert and replace or with and. So De Morgan theorem. This is another two De Morgan theorem are there. We will discuss that in detail in the coming topics. So this similarly the product of the complement of product is equal to the sum of the complemented variables. This is the product of the complement a dot b. There are two the product of variables. The complement of the product of variables is equal to the complemented sum of the complemented variables, So you read that out. We will just go through that quickly. So the same thing are again explained further. These are the commutative laws. You have already gone through that. Distributive law, this a into b plus c is equal to a dot b plus a dot c. This is distributive law. Absorptive law, a into a is obviously a, so you can see that b 1 plus b is equal to that is 1, so we have got a. Associative law, and so on and so forth. So similarly, there are some expressions. Null is defined as 0, identity is a 1, input a. These are some terminology. Not a means complement of a, not a complement not b, like that. A and b means a and b. A and not B means A dot B complement, not and B means A complement dot B, not and NAND gate A dot not means the complement of A and uh, A not and NAND. Okay, so this is A dot B. So similarly, you can see that there are various the terminologies which we'll be using. Here we see further explanation of there is some logical Boolean expression given as A plus B into A plus C. So Q, let's say Q is equal to Q. So this is called multiplying each terms A dot A dot C, A dot A plus A dot C plus A dot B plus B dot C, and you see we are respectively applying the each Boolean law, which is in this case we apply A dot A is equal to A. We have to mention that what we reduce it to the following equation, but by applying the independent law, which is AND law, independent AND law, independent sum law, or the OR law. You can also that later on if you apply that. So A dot A is equal to 1, A is equal to that. And similarly, when you take A common in between, then 1 plus C, so one distributive law we take common, then we 1 plus C is equal to 1, and the identity OR law. Okay, so here we put that 1 plus C is equal to 1. Similarly, that's how we simplify the equations, logical equations. So we are left with the A dot B, B dot C. Further, we can take A common from here. So 1 plus B, again we have distributive law we have applied, and we took the 1 plus B is equal to 1, again A dot B. But we get finally what we got, A plus B dot C. This, you can see that this huge lengthy expression is reduced to such a simple expression. Okay, with this we reach to the end of this topic. We will meet again inshallah with a new topic. Till then, thank you.